Before telescopes and the scientific method, and even before the written word, there was the night sky, an infinite canvas of mysterious shimmering lights. Imagine yourself as an early human, untouched by modern scientific knowledge, standing in absolute darkness. Above you is a vast ocean of flickering points of light that stretches endlessly. What would you think they are? Were they gods, spirits, or messages from beyond? To the earliest humans, the cosmos was not separate from them. It was part of their very existence. The sky wasn't an expanse of distant suns. It was alive, a realm of spirits, ancestors, and celestial forces shaping the world below. Every civilization, from the Babylonians to the Cherokee Indians, wove stories into the constellations. The Greeks traced mighty warriors and fearsome beasts among the stars. The Egyptians aligned their pyramids with celestial markers, believing the heavens guided the souls of pharaohs. Other cultures imagined the night sky as a great dome, its countless pinpricks of light revealing glimpses of a hidden luminous world beyond. But beyond myth, something deeper stirred. Patterns. The stars were not random, they seemed to move with purpose. The moon waxed and waned in a perfect cycle. The sun followed a predictable rhythm. The heavens were not chaotic, they were ordered. Long before modern observatories, ancient civilizations built vast markers of celestial knowledge. Stonehenge, the pyramids, the great ziggurats. These were not just monuments to kings and gods, they were instruments of cosmic insight. The Babylonians, meticulous record keepers, mapped the movements of the heavens with stunning accuracy. They saw more than scattered lights in the sky. They saw patterns, cycles, a silent language written in the stars. Night after night, generation after generation, the sky told a story. It was not random. It was rhythmic, predictable, perhaps even purposeful. The past could be read in its constellations, and the future, maybe, could be foretold. But what was this great mechanism that turned the heavens? Why did certain stars appear only at specific times of the year? And why did a handful of them, the wanderers, defy the others, tracing unpredictable loops across the sky? The ancients were not ignorant, they were inquisitive. They saw order where others might see chaos, connections where others saw chance. They knew they were staring at something profound, something vast, structured, and intimately woven into their existence. The stars dictated the rhythms of life, planting, harvesting, migrating, celebrating, and yet one assumption stood unshaken for thousands of years. Earth was at the center of it all. How could it not be? Everything, the stars, the moon, the sun, appeared to revolve around us. The sun rose and fell along a predictable path. The moon traced its perfect cycle. The stars, vast and unknowable, wheeled overhead in unchanging harmony. The heavens, seemingly flawless and eternal, moved with a rhythm beyond human control. Surely, if the cosmos was so precise, it must have a center. And where else would that center be but right here? This idea was not superstitious or mystical. It seemed obvious. From our point of view, we are stationary. The ground beneath our feet does not move. We do not feel the earth hurtling through space. And everything, the sun, the moon, the planets, and the stars, moved across the sky in orderly, predictable patterns. The entire cosmos seemed to turn around us as though we were the fulcrum upon which the universe itself was balanced. This seemed so obvious that for thousands of years no one thought to question it. The earth was still. The heavens moved. This was the natural order. This was truth. It was so irrefutable and self-evident that it shaped the foundation of all early astronomy. And so, the great geocentric model was born, not from ignorance, but from observation. But observation, as history shows, can be a trickster. In ancient Greece, thinkers sought not just to describe the heavens, but to explain them. If the cosmos moved with such flawless regularity, there had to be a structure, a mechanism governing the celestial order. Plato envisioned a universe of perfection, where the heavens were unchanging and divine. But it was Aristotle who cemented a vision that would endure for nearly 2 millennia. To Aristotle, the earth was motionless, resting at the very center of the universe. Around it, vast crystalline spheres rotated, carrying the sun, moon, and planets in their eternal dance. The heavens were a realm of perfection, composed of an incorruptible substance, the ether, which ensured the planets and stars moved in perfect circles, the most divine of all shapes. This was no mere philosophy, it was the framework of reality itself. And then came Ptolemy, the mathematician and astronomer who gave the geocentric model its most formidable structure. In the 2nd century CE, Ptolemy refined Aristotle's ideas into a model so precise, so mathematically sophisticated, that it could predict the motions of the heavens with remarkable accuracy. But there was a problem. Some celestial bodies, particularly the planets, refused to behave. Instead of moving smoothly across the sky, they performed strange loops, retrograde motion, sometimes appearing to reverse direction before continuing on their path. To preserve the idea of a perfect Earth-centered cosmos, Ptolemy introduced a solution: epicycles. The planets, he proposed, did not simply revolve around Earth. Instead, they traveled in small circles, epicycles, while simultaneously moving along larger paths called deferents. This intricate system of wheels within wheels allowed astronomers to predict planetary motion with astonishing precision. To the scholars of the time, this model wasn't just correct, it was beautiful. It upheld the divine harmony of the universe, aligning with both observation and philosophy. For over 1,400 years, the Ptolemaic system was astronomy. It was written into religious doctrine. It was taught as unquestionable truth. The Earth was fixed, unmoving, at the center of existence, and the celestial spheres turned above in perfect, unbroken order. This was the natural order, this was truth. But nature is indifferent to our truths. Even as the geocentric model reigned supreme, tiny inconsistencies whispered that something was amiss. Some planets seemed to deviate slightly from their expected paths. The moon's motion did not match its predicted cycle with perfect precision. Over time, these irregularities became impossible to ignore. For most, the answer was simple: add more epicycles. Each inconsistency meant more layers, more complexity, more mathematical tweaks. The once simple model of crystalline spheres became an intricate machine of celestial gears, held together by faith as much as mathematics. But in the silence of the cosmos, a deeper truth remained hidden. A truth so radical, so unthinkable, that it would upend everything. And soon, a man named Copernicus would dare to ask the question that no one else had. What if we were never at the center at all? For centuries, the geocentric model stood unchallenged, a grand, intricate cosmic clockwork. It was elegant, it was logical, it was wrong. But revolutions don't begin with chaos, they begin with whispers, tiny, inconvenient inconsistencies that refuse to be ignored. By the late Middle Ages, astronomers had added so many refinements, extra epicycles, shifting spheres, mathematical corrections, that Ptolemy's once simple system had become an unwieldy machine of cosmic gears. The night sky was still predictable, but the explanation behind it was straining under its own weight. Then, in the 16th century, one man quietly placed a single idea at the center of the cosmos. Nicholas Copernicus was not a radical. He was a mathematician, a devout scholar, and a man who revered the harmony of the heavens. But the more he studied the movements of the planets, the more he saw something strange. The geocentric model worked, but only because it was patched and repatched with layers of corrections. What if, he wondered, these complexities weren't corrections at all? What if they were symptoms of a flawed foundation? In 1543, Copernicus published De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, proposing a daring alternative. The sun, not the Earth, was at the center of the universe. Planets, including Earth, orbited the sun. The apparent backward motion of planets, an illusion caused by Earth's own movement through space. The heavens were still ordered, still mathematical, but suddenly they made sense. But the world was not ready for sense. To suggest that Earth moved at all was blasphemy. After all, if the Earth moved, why didn't we feel it? Why weren't we flung into space? And most troubling of all, if Earth was not the center, what did that make us? Copernicus died before his ideas could spark the fire of revolution. For decades, his book was read only by scholars, debated in whispers. But the cracks in the old model had been widened, and soon others would drive them apart completely. One of the first to build upon Copernicus's idea was Johannes Kepler, a brilliant mathematician who, unlike Copernicus, had access to something crucial: precise data. Kepler inherited the detailed astronomical observations of Tycho Brahe, who had spent years meticulously charting the motions of the planets. And when Kepler analyzed that data, he discovered something shocking. The planets were not moving in perfect circles. Instead, they traced ellipses with the sun at one focus. The old Aristotelian idea of celestial perfection crumbled. The universe was not built on divine geometric purity. It was built on something even greater: natural law. Kepler formulated 3 laws of planetary motion, each a dagger to the heart of the Ptolemaic system. His discoveries laid the groundwork for a cosmos governed by mathematics, not myth. And then came the man who would turn observation into proof. For centuries, the heavens had been assumed to be unchanging, perfect, eternal. But in 1609, Galileo pointed a telescope at the sky and saw a universe that defied every sacred assumption. He saw moons orbiting Jupiter, proving that not everything revolved around Earth. He saw the phases of Venus, evidence that Venus circled the Sun, not Earth. He saw mountains on the moon, a direct contradiction of Aristotle's claim that celestial bodies were smooth and flawless. Reality was no longer a matter of faith, it could be seen. But truth is often dangerous. Galileo's findings were condemned by the Church, which saw heliocentrism as an existential threat. He was forced to recant, placed under house arrest, and lived his final years silenced. Yet the truth had already escaped into the world. By the late 17th century, the battle between geocentrism and heliocentrism was no longer about belief, it was about proof. And proof arrived in the form of Isaac Newton. Newton's law of universal gravitation provided the missing key, a force that explained why planets moved the way they did. The same invisible force that pulled an apple to the ground governed the motion of the planets. There were no celestial spheres, no crystalline heavens, just space, time, and the fundamental forces of nature. With Newton, heliocentrism was no longer an idea, it was law. The old cosmos, once built around the assumption of human centrality, was gone. The universe was vast, ordered, mechanical, and humanity, no longer at the center. But the revolution was far from over, because as we pulled away from Earth's centrality, a new question emerged. Was the Sun truly the center after all? The answer would take us beyond planets, beyond the Milky Way, and to the very edges of reality itself. The Sun had claimed its place at the center of the solar system, but was it truly the center of everything? For centuries, the heliocentric model seemed like the final answer. The planets moved in perfect harmony around the Sun, guided by Newton's invisible hand of gravity. The cosmos, once thought to be a fixed and finite system of nested spheres, had been transformed into a vast mechanical ballet of celestial bodies. But science is never content with final answers. The deeper we looked, the more unsettling truths emerged. The Sun, once thought to be the anchor of the universe, was itself adrift in a much greater sea. The cosmos was not just bigger than we imagined, it might be bigger than we could imagine. For over 200 years, Newton's laws ruled the heavens. His equations could predict the movement of planets, the pull of tides, the arcs of comets. The universe seemed to operate like a giant, cosmic clockwork, precise, predictable, and absolute. And then Albert Einstein shattered that certainty. At the dawn of the 20th century, Einstein's theory of relativity upended everything we thought we knew about space and time. The universe was not a rigid, mechanical stage. Space was flexible, time was relative, and gravity was not a force pulling objects together, but the warping of space-time itself. This meant that even heliocentrism was, in a sense, an illusion. There was no absolute center. The motions of the planets, the pull of gravity, the very passage of time itself depended on the observer. The Earth wasn't the center, the Sun wasn't the center. The very idea of a center was meaningless in an ever-expanding dynamic universe. And soon that expansion would become undeniable. For centuries, astronomers believed that the Milky Way was the entire universe, a vast but finite island of stars wrapped in darkness. Beyond it, nothing. Then, in the 1920s, Edwin Hubble peered into the void with a telescope that could see farther than ever before. What he found changed everything. There were other galaxies, millions of them, billions. And they weren't just sitting there, they were moving, racing away from us in all directions, as if the very fabric of space was stretching. The further away a galaxy was, the faster it was receding. The implications were staggering. The universe was not static, it was expanding. If it was expanding, it must have been smaller in the past. If we traced that expansion backward, we reached a single point, a beginning. This was the birth of what we now call the Big Bang Theory. The universe had a history, a moment of creation, a time before which there was no space, no stars, no galaxies, only a singularity, an unfathomable point of infinite density. The old models of a fixed, eternal cosmos crumbled. The universe was not a static machine, nor an orderly, self-contained system. It was a vast, evolving, unfolding reality. As we pushed outward into the cosmos, another revolution was unfolding, not in the grand scales of galaxies, but in the tiny, hidden world of the quantum realm. At the heart of this new understanding was a troubling realization. The universe was not made of solid, predictable objects, but of fields of possibility. Particles could be in multiple places at once. Reality itself seemed to exist only when observed. The building blocks of the cosmos were not things, but relationships, fluctuations, probabilities, and interactions. This shattered any last vestige of a stable, objective universe. Not only was there no center, there was no fundamental stuff at all. Everything, from the stars in the sky to the thoughts in our heads, was an expression of deeper patterns of energy. The journey from geocentrism to heliocentrism was once seen as humanity's great awakening. But now, we see that was only the beginning. We are not at the center. The sun is not at the center. Even the universe itself may have no center. Instead of a finite cosmic structure, we are embedded in a field of ever-unfolding experience. The ancient sky watchers, staring up in wonder, saw the stars as messages from the gods. They weren't wrong to be awed. They just didn't yet know how deep the mystery truly went. And even now, after centuries of discovery, after peeling away illusion after illusion, we are left with perhaps the greatest realization of all. The more we learn, the more we see how little we truly know. The universe is not a mere mechanism to be understood. It is an ongoing revelation. For millennia, humans sought a center. At first, it was Earth, standing still as the heavens revolved around it. Then it was the sun, holding the planets in its grasp. Later, we learned that our sun was just one of billions in a galaxy that itself was one of trillions. And finally, we realized that even the universe itself was expanding, without a center, without an edge, without a fixed reference point at all. Each step was a shift in perspective, a deepening of our understanding. But now a new question emerges. If there is no center, no fixed point in space, no absolute ground, then what is fundamental? For all our advances in cosmology, physics, and quantum mechanics, a profound mystery remains. What is the nature of the observer? As we peeled away the layers of the cosmos, we expected to find an ultimate structure, a foundation upon which everything was built. Instead, we found relationships, probabilities, and fields of potentiality. The classical world of fixed objects gave way to a universe that behaves like an interconnected web of interactions. Particles do not exist in definite states until observed. Reality at the quantum level is not made of things in the traditional sense, but waves of possibility that crystallize into form only in relation to an observer. This realization is staggering. It suggests that the act of observation is not passive, it is fundamental. Perhaps we have been looking at the universe the wrong way. Perhaps instead of a vast external machine that exists out there, we are embedded in a cosmos that is arising within awareness itself. In the old worldview, the universe was separate from us. It existed as an objective thing, governed by unbreakable laws, unfolding mechanically whether we were here to witness it or not. But as we peer deeper into the nature of reality, we find that this model does not hold. Quantum mechanics tells us that reality does not take form until it is observed. Consciousness, the very thing we assumed was a mere byproduct of matter, seems to play a role in shaping what we call existence. This realization is not new. The ancient mystics spoke of it long before modern physics gave us the language to describe it. The Upanishads, Buddhist teachings, and countless philosophical traditions have long suggested that awareness is not inside the universe. The universe is inside awareness. Science, once thought to be the pursuit of the purely external, now finds itself face to face with the one thing it cannot step outside of, the experiencer. The journey from geocentrism to heliocentrism, from Newtonian mechanics to relativity, from a fixed universe to an expanding one, has all been part of a greater shift, from a world of separate objects to a reality of interconnected experience. But what if the final frontier of science is not in discovering more about the external world, but in understanding the nature of awareness itself? Modern physics has pushed us to the edges of what can be known. Quantum experiments suggest that observation plays a role in shaping reality. Neuroscience struggles to explain how subjective experience arises from mere biological processes. And consciousness, this undeniable first-hand reality that every scientist, philosopher, and observer begins with, is still the greatest mystery of all. We once believed we were at the center of the universe, then we learned we were not. But perhaps we are the center in a different way, not as a fixed point in space, but as the very awareness in which space, time, and the universe itself appear. The ancient skywatchers looked up and saw gods in the stars. The first astronomers sought to find the laws governing those stars. The modern physicists found those laws dissolving into probabilities, interactions, and mysteries deeper than we could have ever imagined. And now we stand at the edge of another revolution, not one of planetary motion or cosmic expansion, but one that forces us to reconsider the very nature of reality. Are we truly observing a universe outside of us? Or is the universe an expression of something within us? Perhaps in the end, we have never moved from the center. Perhaps the center was never a point in space at all. Perhaps the greatest discovery is not what lies beyond the stars, but the awareness in which the stars themselves arise. Thanks for watching. Please consider liking and subscribing to support the channel.